I'm Rayesh Uppal, founder of IDST. We bring you sharp insights and foresight on emerging tech, defense, and security. Let's dive in.
Imagine a world where sound can be bent, redirected, or even silenced at will. That's not science fiction anymore, it's the power of acoustic metamaterials, a breakthrough technology that's redefining how we interact with sound. Originally developed for military stealth and defense, these engineered materials are now spreading into everything from healthcare and aviation to consumer electronics and even city planning. So, what makes them different? Traditional soundproofing relies on mass and bulk, thick walls, heavy barriers, dense insulation. But acoustic metamaterials don't play by those rules. Instead of relying on weight, they use precisely designed microstructures that control sound waves in ways nature never could. That means ultra-thin panels that block out city traffic noise, whisper quiet engines, or even materials that make submarines invisible to sonar. The possibilities are staggering. In our cities, acoustic metamaterials could silence the constant roar of highways and construction sites without the need for bulky barriers. Some designs can even be tuned to block only certain frequencies like car horns or jet engines, while still letting other useful sounds like voices or emergency sirens pass through. Imagine quieter streets, peaceful homes, and offices where background chatter simply disappears. In medicine, they're changing the game in imaging and therapy. By bending and focusing sound waves with unprecedented precision, acoustic metamaterials can sharpen ultrasound scans, helping doctors detect diseases earlier and more accurately. Even treatments like focused ultrasound therapy for tumors and kidney stones are becoming safer and more effective. And the future could bring wearable acoustic sensors, tiny devices that track your heartbeat, breathing, or even vocal strain in real time, all without invasive procedures. Military and defense applications are equally transformative. Submarines cloaked with these materials could vanish from sonar detection. Stealth aircraft and vehicles could reduce their acoustic signatures to near silence. And soldiers might use portable acoustic shields to block out harmful shock waves from explosions. In a battlefield where sound is both a signal and a vulnerability, that's a strategic advantage you can't ignore. But the innovation doesn't stop there. Researchers are developing active and programmable acoustic metamaterial structures that can adapt in real time, changing their properties depending on the environment. That could mean walls that cancel office noise during the day and turn into immersive concert panels at night, or drones equipped with ultralight acoustic cloaks that fly silently over cities. Entertainment and communication are also being reshaped. Imagine theaters and concert halls where the acoustics adjust on demand, tailoring the sound perfectly for every performance. Or smartphones with metamaterial microphones that filter out background noise, so your voice comes through crystal clear, even in the busiest places. There are even prototypes of personal sound bubbles where audio is beamed directly to one listener without anyone else hearing it. Of course, there are challenges scaling up production, ensuring durability, and making these intricate materials affordable for everyday use. But with advances in 3D printing, smart materials, and AI-driven design, those hurdles are quickly being overcome. The bottom line is this: acoustic metamaterials are moving out of the lab and into our lives. They promise quieter cities, smarter healthcare, stealthier defense systems, and more immersive entertainment experiences. We're entering an era where sound isn't just something we hear, it's something we can shape, control, and design.